India is a land of massive geographical diversity, containing environments that range from high-altitude ice to tropical coastlines. In the north, the Himalayas form a high-altitude wall where sub-zero temperatures lock moisture into permanent ice and snow. To the west, that landscape shifts into the Thar Desert, a dry expanse of sand where rain is rare and the sun is constant. Across these different regions, atmospheric conditions fluctuate by the hour. A cool morning can become a windy, cloudy afternoon. We experience these short-term, local changes as weather. But when these conditions follow a predictable pattern over months or years, it is defined as climate. The survival of over 1 billion people depends on the consistency of the grand atmospheric engine that governs the entire subcontinent. The Indian Meteorological Department classifies this system broadly as a tropical monsoon climate. It operates in a cycle of 4 chapters that repeat annually: winter, summer, the advancing monsoon, and the retreating monsoon. This table shows how the traditional Indian calendar aligns with the months of the Gregorian calendar. These 6 seasons, or ritu, reflect a deep cultural history of tracking specific atmospheric shifts. This schedule dictates when farmers sow crops, when reservoirs fill, and how the rural economy functions. It operates like a massive scheduled clockwork. To understand the rain, we have to look first at the heat. The dry extremes of the pre-monsoon summer are the spark that ignites the entire system. By May, inland temperatures reach between 32 and 40 degrees Celsius. On this map, the most intense heat is concentrated across the central and northern landmass. Because land heats up much faster than water, the subcontinent becomes significantly hotter than the surrounding Indian Ocean. As this hot air rises, it creates a massive low-pressure vacuum over the land. Moist, high-pressure air from the sea rushes in to fill that vacuum. These winds sweep across the coastline, bringing the first rains of the southwest monsoon. Ancient Arab sailors utilized this seasonal wind reversal for trade across the Indian Ocean. They named it Mausam, the Arabic word for season, and the origin of the term monsoon. The monsoon is more than a storm. It is a thorough dynamic engine powered by the heat of the land, pulling moisture from the sea. As the advancing monsoon moves inland, the shape of the peninsula splits it into 2 delivery branches, the Arabian Sea branch and the Bay of Bengal branch. These red lines chart the normal dates of that advance. The winds typically reach the southern tip in late May and move steadily across the country through early July. The system eventually reverses. By October, the landmass cools down, reversing the pressure dynamics and pushing the air back toward the sea. This map shows the retreat. Between September and November, cold, dry winds move back toward the ocean. As this retreat passes over the Bay of Bengal, it picks up moisture to deliver winter rainfall to southeastern states like Tamil Nadu. This scheduled advance and retreat functions as a massive water distribution system, providing the rainfall necessary to sustain the region. India's food production depends on this cycle. A good monsoon fills the reservoirs and provides the water needed for crops like paddy. However, global climate change is disrupting the engine. Greenhouse gases trap heat in the atmosphere, increasing the intensity of the heat and making the rainfall patterns less predictable. When the cycle breaks, the rains become a hazard. Instead of steady moisture, the atmosphere delivers concentrated, overwhelming floods. In 2025, Punjab faced this crisis. Heavy monsoon rains, intensified by western disturbances, caused the Sutlej, Beas, and Ravi rivers to swell beyond their capacities. Natural rainfall was met with human-made vulnerabilities. Weak embankments and farms built on natural floodplains trapped the rising water, leaving it nowhere to drain safely. The impact was devastating. Thousands were displaced to relief camps, livestock were lost, and critical infrastructure like roads and bridges was destroyed. The Punjab floods demonstrate the danger of this transition. When atmospheric intensity meets inadequate management, the system collapses. survival requires adaptation. This involves both immediate disaster preparedness and long-term efforts to stabilize the climate. Immediate needs include clearing river silt to restore capacity, reinforcing dams, and communicating early flood warnings clearly to rural communities. This section of the text focuses on carbon footprints, the total amount of greenhouse gases released by human activities. Managing these footprints is essential to cooling the global atmospheric engine. Protecting forests, using renewable energy, and adopting sustainable lifestyles are the only ways to address the root cause of the overheating. The prosperity of the land is directly linked to the stability of the atmosphere above it. By protecting this grand atmospheric system, we ensure that the monsoon continues to bring life to the subcontinent for generations to come.